morning to everyone. I am Mrs.N.Akila, Assistant Professor, PG and Research in Department of Mathematics, the Standard Fireworks Rajarathinam College for Women, Sivagasi. My video topic is closed set. In this video, we have discussed about basic definitions for a closed set, its properties and some examples related to closed set. For the first slide, in this slide, we have discussed about the basic definitions for a closed set. The first definition is depends on complement of a set. A set A is closed if its complement A dash is an open set. For the second definition, we have discussed about a limit points. A point X is said to be a limit point if every neighborhood of X intersects of A in at least one point other than X. Then the set A is closed if it contains all its limit point. The third definition is about intersection property. The set A is closed if it can be expressed as the intersection of collection of closed sets which are containing A. For the fourth definition, we have discussed about a closure of a set. The set A is closed if A is equal to A closure. For the next slide, we have list the properties of a closed set. The first property 1 is about union of a closed set. If you take a finite number of closed sets A1, A2, etc. An, their union, that is A1 union A2 union etc. up to An is also a closed set. Therefore, we conclude that finite union of closed set is closed. The second property is about intersection of closed sets. That is, if we consider arbitrary intersection of closed sets, arbitrary means we can take either a finite intersection or infinite intersection, countable intersection or uncountable intersection of closed sets. The result is also a closed set. The third property is about a closure of a set. Every set has a unique closure which is the smallest closure which containing it. These are the basic properties of closed set. Next, we pass on to relationship between open and closed balls. First, we define what is open ball. Open ball B of x comma r is a collection of all y belongs to x such that distance between x comma y which is strictly less than r. Therefore, B of x comma r equal to set of all y belongs to x such that D of x comma y is strictly less than r. For the closed ball, we have considered a selection of, we have considered the set of y belongs to x such that D of x comma y is less than or equal to r. We include the boundary also. These are the relationship between open and closed set. Next, we pass on to relationship between open and closed sets. A set A is open if for every x belongs to A, there exists a positive integer r such that B of x comma r which is fully contained in A. Wherever we define a closed set, a set A is closed if it contains all its limit points. Next, we pass on to a closure of a set A. The closure of set A is denoted by A closure is the smallest closed set which containing A, and it is the union of A and its limit points. Next, we pass on to the definition of interior of A. The interior of a set A is denoted by int of A. It's the largest open set which is containing within A. Next, we pass on to some basic example for open sets and closed set. In R, with standard topology, we consider the set of open interval 0, 1 which is open, and next we pass on to closed interval 0, 1. Here it is a closed set because its complement is open interval minus infinity comma 0 union open interval 1 comma infinity which is open. Next, we pass on to the set closed open interval 0 comma 1 which is neither open nor closed because its complement is open interval minus infinity comma 0 union closed interval 1 comma infinity which is not open. Next, we pass on to the relationship between A closure and limit points of A. The closure of set A, which is denoted by A bar, which is equal to A union D of A, where D of A is the set of limit points of A and D of A is called as derived set of A. We consider the Next we pass on to relationship between A closure and limit points of A. A closure is equal to A union D of A, where D of A is the set of limit points of A and it's denoted by D of A. For this we consider an example. A is equal to open interval 0, 1 union open interval 1, 2. For this set A, these are two disjoint open intervals. Therefore, the set A is open and we consider the closure of A. Its closure is, to find the closure of A, first of all we have to decide what are its limit point of A. That is, D of A is equal to, it's a set of points which is consists of elements 0, 1 and 2. Therefore, A closure is equal to A union D of A, where A is equal to open interval 0, 1 union open interval 1, 2 union the set 0, 1, 2, which is equal to close interval 0, 2. By using this definition, we can easily verify the relationship between A closure and set of limit points of A. Next we pass on to some example for a finite set. Let us consider a finite set 1, 2, 3. For this set is a closed because its complement is open interval minus infinity, 1 union open interval 1, 2 union open interval 2, 3 union open interval 3, infinity, which is open. Therefore, the complement of set 1, 2, 3 is open. Therefore, the set 1, 2, 3 is closed. Next we pass on to the closeness for whole space and empty set. For the whole space, the complement of the whole space is empty, and for empty set, its complement is the whole space M, which are both open in M. Therefore, in a metric space, empty set and whole space is always closed. Next we pass on to the set of all integers. Z is closed because its complement is union of n from minus infinity to plus infinity open interval n, n plus 1, which is open in R. Therefore, we conclude that Z is closed. Next we pass on to the set of all irrational numbers. Next we pass on to set of all rational number, which is not closed because its complement is set of all irrational number which are not open. Therefore, we conclude that the set of all rational numbers Q is not closed in R, as well as the set of all irrational numbers are also not closed. Okay. Next we pass on to some basic problems related to closed set. For the first problem, we have discussed about the definition for a closed set and convergence of a sequence. Let us consider a set A which is contain or equal to R be a closed set, and consider a sequence xn in A that converges to the point x belongs to R. Then which of the statement is true? The first option A discuss about x must be belongs to A, second option is x must be belongs to the boundary of A, and third option is x may or may not be belongs to A, and D none of this. Using the given condition, they are given A is a closed set and sequence xn is a sequence of points in A. We know that A equal to A union D of A. That is nothing but A closure is a collection of points of limit points of A as well as points of A. Therefore, x must be a point of A. So, first option A is correct, that is x must be belongs to A. Next definition. Next we have take the problem S equal to set of 1 minus 1 by n, where n belongs to n. Then what is S closure. S closure is the first option discuss about S A equal to pi, and second option is S union singleton set 0, and third option is singleton set 0, and fourth option is S union singleton 1. And for this we know that S closure is equal to S union D of S. Here D of S is nothing but limit point of this sequence. If you put first element of the sequence is 1 minus 1 by 1, that is nothing but 0, and second option is 1 minus 1 by 2, which is nothing but 1 by 2. Third option is 1 minus 1 by 3, which is nothing but 2 by 3. Proceeding in this way, all of that values are going to number 1. Therefore, D of A is nothing but number 1. So, option D is correct. That is, S closure is equal to S union singleton set 1. For the third thing, we have discussed about a closed set in R per 2. Which of the following sets is closed in R per 2? That is the question. For the first option, set of all x comma y where x square plus y square is less than 1. For this option, they are included all interior points, but they not include its boundary number 1. Therefore, option A is incorrect. For the option B, it is set of all x comma y such that x square plus y square is less than or equal to 1. Therefore, it includes all boundary of points the circle as well as interior points of the circle. So, this is the best option. And for the C, they are take the all the points set of all x comma y where x square plus y square is greater than 1. It is nothing but its complement is set of all x square plus y square is less than or equal to 1. Its complement is closed. Therefore, the option C is not correct. For the option D, set of all x comma y, x square plus y square is greater than or equal to 1. So, it is in its complement is set of all x comma y such that x square plus y square is strictly less than 1, which is open. Therefore, the first option and third options are incorrect. Option B and option D are correct. In this video, we have discussed about some basic definition for closed sets and properties and examples which are related to closed sets. Thank you.